So today we are going to discuss factoring using what's called the greatest common factor. Now, factoring just means we're going to break down or simplify something. And in this case, by finding what each of our terms has in common. Hence, common factor. So, it says step one, we're going to determine the greatest common factor between all of our terms. Then we're going to divide. We're going to write this in factored form. So, here's how this works. There's a couple of ways we can tackle this. We are looking for two things mainly here. And that is the biggest number that you can divide into every term, not just one, not just two, or if there's three, not just three, all of them. And then we're looking for the smallest exponent in common, but I'm going to put a little note below this. If all terms even have exponents. Okay, well, what do you mean, Hardy? So let's say we had something like 27x plus 3. If not every term has an exponent or a variable, we can't take a variable out. So we're going to take the smallest one when we see them, but that's only if all of them have it. So we'll see some examples of that as we go. But we're always going to look for the biggest number that divides in 2. Now that gets to be problematic sometimes, because if we're looking at a problem like we were in the first one, 24 and 30, I can't just say, well, 2 goes into both of them, I'm good. We got to find the biggest one. So how are we going to do that? Either we're going to have to do a little bit of playing around with the calculator, possibly. So we're like, okay, like I said a minute ago, okay, I know 2 goes in, that's cool. Well, what about, what's that? 6, okay. Ooh, now that's looking pretty good. How do I know if it's the biggest one? So there's 2 ways to do this. When I did it with 2, I look at my 2 answers, I'm like 12 and 15. Wait a minute, something can still divide into 12 and 15. 3 can. So I know there's more to it. When I do these, 5 and 4, there's no other number that's going to go into both of those. Now, if what I just said was like, mind blow, here's your other option. On the back of your packet, the very last page, I've got what's called a factor chart. It's the back. You can literally tear it off if you want to, or you can leave it in here and kind of reference it. The reason I put this in here was, here's how you would use this. So I see I've got 30 and 24 here. So what I would do is I would find 30 and 24 on here. And I'm going to go looking for the biggest number I see in each list. So I'm looking through, hey, 6 is the biggest number that I see in both of these. So 6 would be my greatest common factor for these 2. That's an option for you. So here, so step 1, 6 is the biggest number that will go in. Then also I have x squared and I have just plain old x, or x to the first, if I wanted to look at it that way. So I can put 6x or 6x to the first. Biggest number, smallest exponent. Okay? So now, divide each term by the GCF and then the factored form. So we're going to blend steps 2 and 3 together. Maybe for this first one, I will do step 2 to the side. Let's do this. So we're going to take each of these. And we're going to divide it by 6x. Now we got to go back to the memory bank here. We're still going to divide the big numbers normal. Remember, big numbers don't play by little number rules. But now, let's see if we remember this. When we're dividing with exponents, what do you do to the exponents? Subtract them. So 2 minus 1 is 1. And we're going to do that for each term.
Or you could just figure it out.
You can. You absolutely, with this, and 1 minus 1 is 0, so those cancel. Yeah, if you are comfortable enough when you're doing these, that you can just eyeball it and go, 30 divided by 6 is 5, 2 minus 1 is 1, so I have an x there. 24 divided by 6 is 4. 1 minus 1 is 0, so the x's are gone. That's cool. This is where we're trying to get, though. So whether I use the side work or not, that's your call. So now, the only other twist we can have with these is if all of a sudden there is an equals sign in there, we're going to have one extra step. So we're still going to do biggest number that goes into 3 and 12 would be 3. I can get that from my chart. They do both have x, so I can have x or x to the first. And then again, totally up to you if you need the division part or not. So if I'm doing my side work, I've got 3x to the second. It would. 3 divided by 3 is 1. 2 minus 1 is 1. And then you're right. 12x divided by 3x.
That's it.
Now, here's the difference with this one. Once I get here, this is like what we were doing yesterday now. So my last step is to take each piece, so the 3x on the outside, the x plus 4 inside, and set those equal to 0 and solve the mini equations.
So it's 0, so it's 0, 0. Wait, do we have to put it as a point?
No.
Reach for x.
No, we're not looking for any sort of a coordinate today.
And then negative 4. Negative 4.
Okay? Greatest common factor, what's left over when we divide, and then if there's an equals, we solve it. But if there's not, we don't worry about it. So not bad. Not bad. And I think, yeah, that was the only thing I've got for examples, but we'll use them. So now, in the practice packet, okay, for pages 3 and 4 here, on the first page, we're just factoring. We're not solving. So again, let's keep life simple. If I'm looking at 10 and 12, 2 is the biggest number we got in common. Not big. Okay, this time we didn't take an x out because one of my terms didn't have x. They both have to have x for me to take that out, and you're right. 10 divided by 2 is 5. The x is still there. And then 12 divided by 2 is 6.
That's it?
That's it.
Are we ever going to solve it? Solve it all?
No, it'll say equals 0 if we're solving. On this side, we're not solving. He's like, oh, wait. Oh, snap. So let's say, I don't know, let's say we go to 6. We try out 6, and we're like, okay, 30 and 50. 30 and 50.
Wait, how do you do x?
Oh, we're going to check.
Plus, it's just
What's the biggest one here in my list we have in common with 30 and 50?
5. 5.
10.
20.
10. They both have x, but this one again, the plain old x is always x to the first, so that's going to be smaller. And again, when you're doing the next part, we're dividing the bigs, and we're subtracting the littles. Divide the bigs. And 1 minus 1 is 0, so I don't have another x that I need here. The other thing I'll tell people is, if you're not sure and you get to an answer at the end, try to distribute and see if you get it back. 10 times 3 is 30, cool. 1 plus 1 is 2, good. 10 times 5 is 50, okay. There I have x to the first, and I already have x to the first there, I'm good. One more on this side I want to do. 7 is the one I want to hit. Because I look at 7 and I'm like, well, wait a minute. 3 and 7, the only thing they have in common is 1. Like, do I pull out a 1? I don't really need to. I mean, you could. I can take an x, though. But the cool thing here is, what happens when you divide by 1?
It equals.
Like nothing, it's the same thing. So, again, 1 plus 1 is 2, or 2 minus 1 here. Negative 7 divided by 1 is still negative 7. 1 minus 1 is 0, no more x's. Yeah. So, yeah, when you're looking down at the answer boxes, like if you look here, you're like, okay, is this and this the same thing? Yes. Me having a 1 there or not is really not changing anything at all. So, yeah, if sometime you have a 1 somewhere and you don't see it down here, like on this one, these absolutely are the same thing. It's true. That's all good. So on this side, just taking that greatest common factor out and putting the leftovers inside when they're divided. When we get to the back, though, you're like, uh-oh. A couple of things. Okay, before we get to the equals 0 ones, there's a little bit of craziness up here at the top. I'm like, all right, let's see here. All right, so I'm looking at my 12 and my 18 boxes here. What's the biggest number in the 12 and 18 box? 6. Okay, so we take out a 6. Look at each variable separately. Look at the x's. Take the one with the smaller exponent. Look at the y's. Take the one with the smaller exponent. Once I've done that, now this may be one that it's worth it for me to do a little bit of side work. Now, that's kind of your call.
So it'd be 2,
So let's see.
2.
So I took my first term. 12 divided by 6 is 2. I'm with you. X3 minus 1 is 2. And the y's cancel out. There's no y here, okay? Now, if you can just visualize that and do it in your head, that's fine. But if not, what I'm doing here is absolutely not a bad idea. 18 divided by 6, again, if you have struggles with that, use the calculator. Shoot. 1 minus 1, x's cancel. 4 minus 2 is 2. It's the exact same process. We just have one extra variable in there. And we're just going to keep working through that. That's what those three are going to look like. And then the only difference when we get to the last section is that once we factor, we're actually going to set the factors equal to 0. So let's play with a couple. 5 and 30. Okay, 5 and 30. We got 5. That makes sense. They both have an x, so we just take the one without the exponent. That's as small as it gets. If you want to put the 1 there, we can. And we start the division game again. Divide the bigs. 5 divided by 5 is 1. I mean, you can put a 1 or you can just put nothing there. That's fine. 2 minus 1 is 1. Negative 30 divided by 5. Negative 6. And 1 minus 1 is 0. Normally we'd be done, but that equal sign's there now. So we're going to take the 5x and set it equal to 0. We're going to take the x minus 6. You can put the 1 if you want. You don't need to, though. And set it equal to 0. And then just solve the two little mini equations. Doing my opposites. Oh, let's do one more. How about 17? All right, what's my biggest number that goes into 8 and 17? I mean, 8 and 20. Sorry, that's the problem number. What is my largest factor with 8 and 20? Yes, I'm still here. Oh, folks. We're not going to communicate and think through things. It ain't going to get better. Oh, bigger than 2.
Huh?
Bigger than 2.
It's 8. It's 4.
4. Smallest x.
4x minus 2x plus 5.
Yeah, and again, keep telling yourself in the head over and over, divide the bigs minus the littles. And again, whether you put x or x to the first, either is fine. Divide the bigs. Subtract the littles. 1 minus 1 is 0. So I do not put another x here. And now we're to the point of truth. Each one of my pieces that has an x gets set equal to 0. Hardy, is 0 always going to be one of the answers? Not every time. And we just got to trust our problem solving or our equation solving skills.
This is real. I would never do. I said it was.
The big thing today is get used to using the factoring sheet if you need it, and then just following those basic rules. Even if you only did, let's say, a couple in each section, it's probably going to reinforce it well enough for you to have it click long term. So try those out, kind of see how it goes.